Hi viewers, this is Electronics Hub instructor team from Kamraj College of Engineering and Technology. Today we shall see the experiment on study of logic gates.
Next we shall see the XOR gate. It is called as exclusive OR. Its pin IC number is 7486. This is the truth table of the XOR gates. Whenever both the inputs are same, the output will be at the logic 0. Output is logic high only when both the inputs are different. XOR is also called as a controlled inverter. What is the function of inverter? The output will be the inverse of the input. So you can see that whenever one of the input is 1, output is the complement of the other input. So here one of the input is 1. So the output is the complement of the other input. Other input is 0, its complement is 1. Here the other input is 1, its complement is 0. Other thing is whenever one of the input is 0, you will be getting the other input at the output. So here the input is 0, the other input is 0, so the output is 0. Similarly, the other input is 1, so the output is 1. So it is called as a controlled inverter. This is the symbol of XOR gate, Y equal to A XOR B. This is the complete diagram. This is equivalent to A complement B plus AB complement. It is a 2-input gate. This is a pin diagram. Similar to that of the AND gate, 1, 2 is the input, 3 is the output. Similarly, 4, 5 is the input, 6 is the output. Similarly, 9, 10 is the input and 8 is the output. 13 and 12 is the input and 11 is the output. The application of this XOR gate is in the case of a terrace light. In case of a terrace light, you have one switch inside the house and another one in the terrace or outside the house. So the same logic is applicable for light to glow. Assume that the switch that is inside the house is A and that is outside the house is B. So if both the switches are in either off state or in the on state, the output will be in logic 0. That means the light will not glow. But if the switch inside the house is at logic 0 and the switch outside the house is at logic 1 or vice versa, the output will be at logic high. That means terrace light will be glowing. This is the application of the XOR gate. This is the workbench where we will be doing the experiments. Each workbench will be having its own power supply. So you have to turn on the power supply first. Then you have to turn on the switch to which your trainer kit is connected. This is your IC trainer kit where you are going to check the condition of the gates. It is having input and output. Each of the input and each of the input is connected with an LED which indicates the output whether it is logic high or logic low. Then this is having for connecting the ground and the VCC, you are having 5 volt VCC and 12 volt VCC. Then you have ground corresponding to that. Then you have clock signal and you have a ground pin here. This is a breadboard where you will be connecting your IC. This is your IC. You can see that it is a 14 pin. You have to identify the pin number 1. For that, see you have a notch here. Below the notch, you have a circle and the pin below the circle indicates the pin number 1. Now we can see how to place the ICs. ICs has to be placed in this gap like this. It should not be placed anywhere in the breadboard. Now I shall show you how to connect the VCC. Similar to that, you can connect all the other pins. Just insert your wire inside the hole. Tight this button and connect it to the 14th pin. Then the ground, similar to that, connect the ground in the 7th pin. These are my 2 inputs. I am connecting inputs in pin number 1 and pin number 2. From the pin diagram you can see that 7th pin is the ground, 14th pin is by VCC. I am using this gate now for checking purpose. So I am giving 1 and 2 as the input and output is in pin number 3. Now after connecting this, ensure that you have connected the VCC and ground. Now turn on the trainer kit. So what from the truth table you know that if both the input are same in the same state, that is if they are in logic 0 or if both the inputs are in logic 1, the output will be in logic 0. So first I am making both the inputs 0. So both the inputs are at logic 0, so the output is at logic 0. Now I am making both the inputs logic 1, the output is at logic 0. Now I am turning one of the input to logic 0. The output is at logic 1. I am turning input A to logic 0 and B to logic 1. Then the output is at logic. Now we shall see the implementation of the application of staircase slide. Assume that this is the switch in the ground floor and this is switch in the top floor. Whenever both the switches are in the same condition, that is now I am assuming both the switches are in the off state, then what will be the output? According to the truth table, if both the inputs are in the same state, the output will be at logic 0. So the output is at logic 0. Now I am assuming both the switches are in the on state. If both the switches are in the on state, output is again at the logic 0. That means the bulb will not be glowing. Now I am assuming that the switch that is in the ground floor is in on state and that in the top floor is in the off state. So what happens? The bulb will be in the on state. Now assume the opposite condition. The switch that is in the ground floor is off state and that in the top floor is in the on condition. Then also what will be the output? Since both the switches are in the opposite condition, the bulb will be glowing. This is the application of the XOR gate.